Before sunrise, the water surrounding Seal Island appears almost black. Thousands of Cape fur seals crowd the rocks above the surface. But some are already entering the sea. Others are returning from offshore feeding grounds, crossing a narrow stretch of deep water to reach the safety of the colony. They swim quickly, but the darkness beneath them hides something they cannot see. Far below the surface, a great white shark is waiting. It does not chase immediately. It remains deep, using the dark water to conceal its pale underside and enormous body. Above it, the first light of morning turns the returning seal into a moving silhouette. The shark begins to rise. Its tail accelerates. Its muscles generate a sudden burst of power, and several hundred kilograms of predator move almost vertically through the water. By the time the seal senses the attack, the shark is already beneath it. The jaws open. The surface explodes. Predator and prey are launched into the air together. This is the breach ambush, one of the most dramatic hunting strategies in the ocean, and one of the clearest demonstrations that a great white shark is not simply a powerful animal. It is a patient hunter capable of using depth, light, timing, and experience to create a moment in which escape becomes almost impossible. Seal Island lies in False Bay near Cape Town, South Africa. The island is small, rocky, and crowded with Cape fur seals. For a great white shark capable of hunting marine mammals, it represents an extraordinary feeding opportunity. But the abundance of seals does not make every attack easy. Adult seals are fast, agile, highly alert, and capable of turning far more sharply than a large shark. A seal that detects the predator early can change direction repeatedly, rush toward shallow water, or remain close to other seals. The shark's greatest advantage is therefore not a long pursuit. It is surprise. The water around parts of Seal Island drops into deeper channels close to the colony. These depths allow a shark to remain hidden beneath the path used by seals traveling to and from the island. The shark's dark upper body blends with the water when viewed from above, while its white underside becomes difficult to distinguish from the brighter surface when seen from below. This countershading helps conceal the animal from different directions. But during an upward ambush, the darkness below provides the greatest cover. The shark positions itself beneath the seal and begins its final approach from depth. It cannot attack slowly. A gradual ascent would give the seal time to detect movement and escape. The shark must accelerate rapidly, converting the vertical distance into speed. Its crescent-shaped tail pushes powerfully from side to side. The body stiffens. The pectoral fins help control the angle, and the nose remains directed toward the prey above. The strike may occur within only a few seconds. The shark travels upward so quickly that its momentum can carry its entire body clear of the water. A breach is therefore not necessarily the purpose of the attack. It is the consequence of extreme speed continuing after the shark reaches the surface. From a distance, the event looks chaotic. Water erupts. The shark twists through the air, and the seal may disappear inside the jaws. But the approach beneath the surface is controlled. The shark has selected the direction, depth, and moment of acceleration. It has aligned its body with a moving target and predicted where that target will be when the two paths meet. The attack often begins during the dim period around sunrise. Low light makes it harder for the seal to see into the depths, while the brighter surface can reveal its silhouette to the shark below. Studies at Seal Island found that predatory success was highest near sunrise and declined as the surrounding light increased. As the morning became brighter, the seals gained a better chance of detecting the approaching predator. The shark's hunting schedule is therefore linked to the sun. Darkness provides concealment, but complete darkness could also make tracking the seal more difficult. The first light creates a useful imbalance. The shark remains hidden in the deep water while the prey becomes visible against the surface. This window does not remain open for long. As the sun rises, active predation usually decreases. The sharks can still hunt, but the energetic return becomes less reliable. A failed attack requires the shark to recover, reposition, and search for another target. Repeatedly chasing alert seals in bright water would waste energy and increase the risk of injury. The great white does not continue hunting simply because prey remains present. It responds to the probability of success. When conditions become unproductive, the shark can stop attacking and conserve energy for another opportunity. This is not the behavior of a mindless predator controlled by endless hunger. It is the behavior of an animal making decisions about cost and reward. The seals also change their behavior according to risk. Returning alone creates a more vulnerable target. A solitary young seal has fewer animals around it to detect danger, and no confusion created by a tightly packed group. Sharks at Seal Island have been observed disproportionately targeting young seals returning to the colony near the surface. Young seals may be fast, but they lack the experience of older animals. They may travel along predictable routes, fail to recognize subtle warning signs, or react too late when the water beneath them begins to change. Their smaller bodies also provide less strength during a struggle. The shark does not always attack the nearest seal. It may allow a group to pass while waiting for a more vulnerable individual. A lone animal separated from the others presents a cleaner approach. The shark can concentrate on one silhouette without choosing among several bodies moving in different directions. This selectivity reveals that the breach is only the final visible stage of a much longer process. Before the explosion at the surface, the shark has already searched for prey, evaluated group size, selected a target, moved beneath it, and chosen an angle of attack. Some strikes rise almost vertically. Researchers have described this as a Polaris attack, named after the North Star because the shark travels upward through the water column. Other attacks occur at diagonal angles, depending on the seal's direction, the depth of the shark, and the structure of the surrounding water. A vertical strike offers several advantages. The seal has limited awareness of what lies directly beneath it. The shark can build speed over a longer distance, and the attack drives the prey away from the horizontal escape routes it normally uses. Instead of pursuing the seal across the water, the shark intersects its path from below. The first contact is often devastating. The shark may seize the seal in its jaws or strike it with enough force to cause severe injury. If the bite lands near the rear of the body, the seal may lose the ability to swim effectively. Damage to the abdomen, hind flippers, or spine can reduce the agility that normally protects it. A successful first strike is important because a wounded seal remains dangerous to pursue. Cape fur seals are not passive prey. They can turn sharply, bite the shark, and use their agility to remain behind the predator's head, where the jaws cannot easily reach them. If the shark misses its initial ambush, the encounter changes from a surprise attack into a contest of maneuverability. The seal may begin zigzagging across the surface, changing direction each time the shark approaches. The shark is faster in a straight line, but its large body cannot turn as tightly. The seal uses this difference to survive. Some seals even move toward the shark during the pursuit, forcing the predator to turn before it can attack again. The maneuver seems suicidal, but approaching the shark's head from an angle can make it difficult for the predator to align its jaws. The seal survives by remaining too close, too unpredictable, or in the wrong position for a clean bite. This is why the ambush matters so much. The shark wants to end the encounter before the seal can use its agility. A perfect strike incapacitates the prey immediately. An imperfect strike begins a far more difficult chase. Even when the shark catches the seal, it may release it temporarily. Great whites often use a powerful initial bite, then move away while the prey weakens. A struggling seal can cause injury, and the shark's eyes are vulnerable during close contact. The predator may wait nearby before returning. During the bite, the shark can roll its eyes backward or protect them as it enters the most dangerous stage of the attack. Its primary senses have already guided it toward the prey. At close range, the shark also detects electrical signals produced by muscle activity through sensory organs around its snout. These organs help it locate living targets when visibility is poor. But the breach ambush depends on an entire combination of sensory information. The shark can detect vibrations and movement through its lateral line system. It can smell biological material in the water. Its vision helps identify contrast and motion above. No single sense explains the hunt. The predator combines information from the surrounding environment to construct a picture of a seal it may not see clearly until the final approach. The water itself carries clues. A swimming seal creates pressure waves and turbulence. Repeated movements of its flippers disturb the surface. A great white waiting below can detect parts of this activity while remaining concealed. The shark must also avoid revealing its own position. A sudden turn, movement near the surface, or visible dorsal fin could warn the seals. Remaining deep allows it to approach without creating an obvious surface disturbance. The ambush is therefore a contest of information. The shark tries to collect as much information as possible while giving the seal almost none. The seal survives if it detects the predator before the acceleration begins. Once the shark has reached full speed beneath it, the time available for reaction may be measured in fractions of a second. Not all great white sharks perform the attack with equal skill. Long-term observations at Seal Island have revealed differences between individuals. Some sharks appear more successful than others. They may choose better targets, approach from more effective angles, or time the strike more accurately. These differences suggest that experience matters. A young shark does not automatically become a perfect seal hunter upon reaching the correct size. It may need to learn through trial and error. A failed strike provides information about distance, speed, and prey reaction. The next attack can be adjusted. An inexperienced shark may open its jaws too early, rise behind the seal, or begin its acceleration from the wrong position. It may breach spectacularly, but capture nothing. To human observers, the leap is still impressive. To the shark, it is an expensive failure. A more experienced individual may approach with less visible drama, yet achieve a higher success rate. The goal is not to fly through the air. The goal is to contact the seal at the correct moment. A breach without prey can represent too much speed, poor alignment, or an evasive movement by the target. Hunting skill can develop over repeated seasons. Sharks return to regions where marine mammals gather, encountering similar environmental conditions and prey behavior. They may learn the most productive locations around an island, the routes commonly used by young seals, and the times when light provides the greatest advantage. Memory can transform a stretch of ocean into a map of opportunities. One channel offers sufficient depth for acceleration. Another is too shallow. One side of the island receives returning young seals in the early morning. Another contains too much disturbance or competition from other sharks. Competition can alter the hunt. When several great whites concentrate in the same productive area, each shark may face pressure to attack quickly before another predator reaches the target. This can lead to poorly timed or less selective strikes. Research at Seal Island found lower success in locations where predatory activity occurred most frequently, suggesting that the presence of other sharks may influence individual decision-making. The animals are often described as solitary, but they do not hunt in a social vacuum. Each shark can detect competitors and respond to their presence. A shark may attack a seal under imperfect conditions because waiting could allow another individual to take the opportunity. The result is a decision shaped not only by the prey, but also by nearby predators. The sharks do not cooperate like orcas. They do not form a team, divide roles, or share a planned attack. But the behavior of one shark can still affect the choices of another. Competition changes the cost of patience. The seals also learn. Individuals that survive attacks gain experience with the locations and conditions associated with danger. They may travel in groups, remain close to the island, avoid predictable routes, or change the timing of their movements. A group of seals creates confusion. Many bodies turn and dive together, making it harder for the shark to select and track one target. More eyes are available to detect danger. If one seal reacts, others can follow. The shark responds by targeting individuals separated from this protection. Predator and prey continuously influence one another. Better ambushes favor more cautious seals. Improved seal defenses favor more selective and precise sharks. The spectacular breach is therefore part of an evolutionary contest. Every successful attack rewards concealment, timing, and speed. Every escape rewards awareness, agility, and social behavior. The location itself shapes the contest. Seal Island provides a concentrated prey colony beside deep water. Without this combination, vertical breaching attacks might be less common. A shark cannot build the same upward speed if the water is shallow, and seals spread across a wide coastline may be more difficult to predict. This is why the famous behavior is strongly associated with certain places. Great white sharks live in many regions, but they do not hunt in exactly the same way everywhere. Along another coastline, a shark may patrol kelp forests, follow migrating seals, scavenge whale carcasses, or attack horizontally near the surface. The species possesses a flexible set of abilities. Local geography and prey behavior determine which strategy becomes effective. At Seal Island, depth and light create the conditions for flight. The word flight is almost appropriate. During a full breach, the shark can leave the water completely. Its fins spread away from the body. The tail may continue twisting as momentum carries the animal upward. For a moment, a fish evolved to live entirely beneath the surface is suspended in the air. But the body is not designed to land. The shark crashes back into the water with enormous force. If it has captured the seal, it must regain control while holding the prey. If it has missed, it must recover from the impact and begin searching again. The physical cost makes repeated breaches unlikely without a good reason. The shark cannot perform them simply for spectacle. Each acceleration consumes stored energy, and the animal may not feed every day. Large meals can support it for extended periods, but every failed attack reduces the energetic return of the hunting session. A seal provides a valuable reward because its body contains energy-rich fat. Marine mammals offer more calories than many fish of similar size, but they are also more difficult and dangerous to catch. The shark's warm muscles, powerful tail, serrated teeth, and ambush strategy allow it to access this food source. Great whites possess a specialized heat exchange system that keeps parts of their swimming muscles, brain, and sensory organs warmer than the surrounding water. This partial endothermy improves performance in cold seas and allows rapid acceleration during an attack. Heat does not make the shark fully warm-blooded like a seal, but it gives the predator an advantage over most fish. Its muscles can remain ready for explosive action, even while the shark waits in cold, deep water. The cost is a higher demand for energy. A high-performance body must eventually receive a high-energy meal. This creates another reason to choose attacks carefully. The shark cannot waste endless accelerations on prey it is unlikely to capture. Its reputation suggests constant violence, but much of its hunting time is spent not attacking. The shark patrols, observes, changes depth, and waits. The visible explosion lasts seconds. The hidden preparation may last far longer. Somewhere beneath Seal Island, a great white moves through cold water before sunrise. Above it, hundreds of seals enter and leave the colony. Most remain too close to the rocks or travel inside groups. The shark does not respond. Then a young seal appears alone. Returning across deeper water, its body creates a dark silhouette against the growing light. The shark turns slowly until its head points upward. For several moments, nothing appears to happen. The distance between predator and prey begins to close. The seal continues swimming, unaware of the body directly beneath it. The shark accelerates. Its tail moves faster. Water rushes along the skin. The pectoral fins adjust the angle while the jaws remain closed to preserve speed. The silhouette grows larger above. At the final moment, the mouth opens. The upper jaw lifts, exposing rows of serrated teeth. The shark strikes the seal from below and continues through the surface. Water explodes into the morning air. The shark's body rises clear of the sea, twisting with the seal between its jaws. For an instant, both animals are visible against the sky. Then they fall. To the people watching from a distant boat, the event looks sudden and almost impossible. But the attack began long before the breach. It began when the shark selected the correct depth, waited for the correct light, ignored the protected seals, and focused on one inexperienced animal moving alone. The leap is not an act of rage. It is the final answer to a carefully constructed problem. Depth gives the shark room to accelerate. Darkness hides its approach. Morning light reveals the prey. The seal's isolation removes the protection of the group. Speed shortens the time available for escape. Experience guides the jaws toward the point where the target will be. When all these elements align, the ocean's surface becomes the meeting point between two worlds. The seal is attempting to reach the safety of land. The shark is rising from the darkness below. For a fraction of a second, both leave the water entirely. This is why the breach ambush remains one of the most extraordinary hunting behaviors ever observed. It transforms a predator known for swimming into an animal that appears to fly. But the true wonder is not the height of the leap. It is the intelligence hidden beneath it. The great white does not conquer the seal through strength alone. It controls what the seal can know. It attacks from the one direction the prey cannot easily watch. During the brief period when light favors the hunter, and with enough speed to make reaction almost meaningless, above the surface, the event is an explosion. Below it, the hunt is silence, calculation, and patience. And by the time the ocean finally erupts, the most important decisions have already been made.